Okay, we're going to talk a little bit today about transformations, specifically translations here. And so this is taking a graph and moving it left and right, up and down, around to different positions, just from a regular parent function graph. So the equation here, when I've got f of x equals x, and remember, we can just think of that as y equals x, because f of x and y are really the same thing. F of x just talks about it as a function, so we never get a vertical line with that. A lot more that being a function kind of goes to, but for us right now, we can say f of x, we can just think y, they're the same thing. This equation, it's the parent function of a linear function, so linear parent function, and it's basically the simplest equation you can write, the simplest thing that gives you this type of graph. So this is the most basic equation that will give you a line, just y equals x. On Desmos, I could put in x, and it would graph this line. In TI-84, same thing. And so every linear equation that we have is basically this, just with the transformation of that. So just a transformation of this parent function. So let's do this. We're going to fill in the table. If y equals x, then that means if x is negative 5, well, y is going to be negative 5. If x is negative 3, y is going to be negative 3. And so on and so forth. Every single point will kind of match up there. So we can really just put points wherever along this diagonal line and know this is where that's going to line up. So right along that line, we draw our straight line. It's not perfect going through there, but it'll work. So there's our linear function there. So looking at a couple of the key features of this, just a straight diagonal line with a positive slope. So our slope on this, rise over run, it goes up 1 to the right 1, or up 5 to the right 5. Slope of it would just be a 1 then. The x-intercept, it crosses the x-axis at 0, 0. And so the y-intercept is also 0, 0. And so you notice on this, when we say it's a slope of 1, I could put a 1 there and it'd say y equals 1x. Y-intercept is 0, so I could say plus 0 there. And so when we're looking at transformation, a change in the input, or the x value, causes a horizontal change. And so a change to the output, or f of x, causes a vertical change. And so we would call that a translation. It's a transformation that slides it horizontally or vertically, so we could call it a shift. And so it just shifts the line left, right, up, down, any of that. So if we have a vertical shift, if we have f of x is just y equals x, and so the way I would write this is, for a vertical shift, would be the y equals x plus 4, or y equals x minus 5. So the way it looks here kind of overcomplicates it. If we're doing y equals x plus 4, well, that's taking this line and saying, well, and the slope's still 1. The y-intercept now is just 4. And so I can say y-intercept is 0, 4. Our slope's going to stay the same. So slope of -1 means that's going to hit the x-intercept at -4 down here. And so x-intercept, -4, 0. Okay, and so remember this when we talk y and x-intercepts. The y-intercept is a part of the graph, or a part of the equation, that +4. This x-intercept has nothing to do with the equation here. Okay, the 1 that's up here, that's the slope, the rise over run, so that doesn't change. Same thing here. If we do -5, then I get a line that goes up 1 to the right 1, and so my y-intercept is 0, -5, and we notice hopefully that if I've got that right there, that's just our y-intercept. So if that's the only change happening, then we get a y-intercept right there, just like that. X-intercept would be 5, 0. And we figure that out from the slope. And so the notation will be f of x plus d shifts the graph that many units up. If we have f of x minus d, it'll shift it down. So that's shifting it either up this way, or this one, it shifted it down. Okay, and so just looking again at a regular line that we have there, putting a number on the end like that shifts it up or down. Now looking at it another way, if I have a horizontal shift, so this is if I have the graph y equals x minus 3, and so my slope here is still 1, it's going to change this a little bit. So when I've got y equals x minus 3, what happens here is since I've got a slope of 1, it's going to actually move it the opposite way. And so I think minus 3 normally would move it this way. But what happens here is to get it to 0 out, when y is 0, x would equal a positive 3. And so we can think about that as a table. Do a quick little table here. If we put 0 in for x, y would equal -3. If I put in a 3 for x, 3 minus 3 would be 0, just to give us a couple points. So what happens is it shifts it right, actually 3. And so it goes through there, down like that. And so it's shifting it to the right. So my y-intercept would be the 0, -3. X-intercept would be 3, 0. Okay, so it shifts it kind of the opposite of what we would expect. So that means here, if we've got plus 6, that's y equals x plus 6. Then thinking about a table again, if I put in 0 for x, so when x is 0, y would be 6. If x is -6, that would give me a 0 for y. That basically keeps our slope the same. And we would view this as a shift to the left. So that would give me a y-intercept of 0, 6, x-intercept of negative 6, 0. And so the way this works, because you're probably saying, well, wait a minute, don't they really do the same thing? Because it's just minus 3 plus 3. Right now it looks like they do, but what's going to happen is if I add a slope to that, like we'll do in the future lessons, if I had a slope of 3 here, I would do 3 times x is 3x. 3 times negative 3 would be negative 9. This one, if I had a slope of 3, I would just say that would just be 3x plus 4. So the y-intercept would stay the same, and it would adjust it from there. For this one, the x-intercept would stay the same, and the slope of 3 would adjust and change the y-intercept. So that's a little bit of why we do that. The notation that we're doing for now, f of x minus c, moves it right. F of x plus c moves it left. Okay, so looking at the couple of things down here, just real quick, we're just going to say, how did this move it? So if it's outside of the parentheses, it's regular up and down. So minus would be down 19.5. Inside the parentheses is left and right, and it's opposite of what we think. So left 17. Inside the parentheses again, so right 8. And outside would be up 25. And so that's the basics of our parent functions there. In class, we'll be going over putting it in Desmos and saying, like, look visually at what happens when I add something to this versus when I add something to the other part, and actually put in some points and use it that way. But this is the basics of transformations. As you go further along in math, this knowing what a parent function is and knowing this format of adding something to the end moves it up and down, adding something inside with the x moves it right and left. Knowing that is going to unlock so many things for you, is going to make a lot of what happens in math easier for you from a graphing standpoint if we can understand how those transformations work.